Yay, you're still here. Now we're going to get the derivative of the loss with respect to wj, which is what we were asking for in the very beginning. We're going to use those three derivatives that we calculated in the past three videos and multiply them together and then simplify everything. The nice thing is, no more calculus, just some arithmetic. Let's take a look. So again, we have this expression here, the chain rule, and now we're going to get the derivative of the loss with respect to wj. And as a reminder, this is what you saw in the course videos. The derivative of the loss with respect to wj is f of x minus y quantity times x sub j. So how do we get there? Well, the derivative of the loss with respect to f is this expression, which we saw in a previous video. And then the derivative of f with respect to z is this expression, which we also saw in an earlier video. And the derivative of z with respect to wj is this expression here, just x sub j, which we also saw previously. So we'll just multiply these together and then we'll get what we're looking for. Now if you look at f times quantity 1 minus f, we're going to distribute that to these two terms here, and so it will look like this. You can see that f times 1 minus f is now distributed in the first term and also in the second term. And let's just cancel out some terms. So 1 divided by f times f is just 1, and also 1 over 1 minus f and 1 minus f cancel each other out as well. So if we clean that up, it looks like this. Next, let's distribute this negative y over here, and also let's distribute this f over here. If we do that, here's what we get. And let's cancel out some more terms. This positive yf and this negative yf cancel each other out. So you're left with negative y plus f quantity times x sub j. And we'll just flip that around so it's f minus y quantity times x sub j. Pretty cool, huh? So now you have this expression here that you saw in the course videos. Congratulations! You've seen how all this math simplifies into this beautiful, simple equation. Now there's just one more thing to do, and that's to go from the loss function to the cost function. Remember, in the courses, Andrew refers to the loss to refer to a single training example, and the cost to refer to the average over all training examples. So remember, the cost is just 1 divided by m times the sum of all the losses for all the training examples. So if you take the derivative of the cost, that's just 1 over m times the derivative of the loss, which is this expression right here. So that was how to get the derivative of the cost j with respect to the parameter wj. How do we get the derivative of the cost j with respect to the parameter b? The cool thing is, getting the derivative with respect to b is going to be very similar, and in fact it's going to let you reuse a lot of what you learned in the past couple of videos. So you can actually see how this is done all in one more video. So you have one more video to go and your life will be complete. So let's go on to that last video.